Okay. So today we're going to be taking a look at inverses of functions. Okay, and kind of like yesterday when we talked about inverse trig functions, we did a little review first from pre-calculus. We're going to do the same thing here because it's helpful before we move into what we're going to be learning today, the calculus part of it. So first we're going to just review a little pre-cal. All right. So a function, in a very basic sense, is just a relation, okay, between two groups of things. Typically in mathematics, we see that as like a set of ordered pairs. Math is hilarious. Actually, in Australia, we say maths, like it's plural. You guys just say, yep, just like in England, How many times I've been to Australia? Well, I live there, so practically all my life. How many times I've been to America? It's my first time, so it's very exciting.
And then there's a place where crocodile live.
That's right. Steve Irwin, national hero.
Did you know that I have a Steve Irwin college?
Is that right?
Yeah.
Fascinating. Okay. Back on track though, we still have some maths to learn, so let's go on. So, if we've got our function here, right, real basic sense, no rule, right, just kind of like, here it is, okay, we don't know how we come up with these numbers, but we've got them. The inverse then, if we took the inverse of f, that's exactly right, Adric, we swap the x's and the y's. So we end up with, instead of 1, 4, 4, 1. Instead of 2, 5, becomes 5, 2. Okay? 3, 6 becomes 6, 3. 7, 4, 4, 7 becomes 7, 4. Okay? And this kind of makes sense because if you remember, when we take inverses of functions, what's like the first step that we do? Yeah, we swap the x's and y's. Exactly right, Adric. Okay? So, when we find an inverse, we're swapping the x's and the y's, and when we actually just literally do an inverse, we swap the x's and y's. It kind of like, they swap places and then we maybe solve for y or whatever. So, the definition, okay, of an inverse function so a function g is the inverse of the function f if, okay, so again we're talking about got a function g and a function f. We say that g is an inverse of the function f if f of g of x equals x. So what that means is you take the inverse of g, you plug it into f, okay, and if it simplifies down to just x, then that's part of it, but there's a second part. And, so this also must be true, g of f of x also must equal x. Okay? If both of those things are true, then we say that g is the inverse of f, and vice versa. F is the inverse of g. Okay? So you plug one function into the other, should simplify down to x. Plug the other function into the one, simplify down to x. Okay? So, as a quick example of that, we're going to show that the functions are inverses of each other. Okay, give you an example here. And here are the two functions. F of x is, let's say, 2x cubed minus 1. Alright, and g of x is the cube root of x plus 1 all over 2. So, let's try it out here. Let's see if this works. So again, if it works, then if I plug G into F, it should simplify it down just to plain old X there. So let's see if that happens. So I'm going to take F of G of X. Okay. So instead of 2x cubed minus 1, what's going to replace that x? The cube root of the x plus 1 all over 2. That's right. So it's going to be 2 parentheses cube root of x plus 1 over 2 cubed minus 1. Don't forget all the other stuff too, right? So right, cubing a cube root, they cancel. And we're left with twice the quantity x plus 1 over 2. But then what else cancels here? The 2's do, right? It's 2 times something divided by 2, so it also cancels. And then x plus 1 minus 1 gives us just plain old x. And there we go. So right, are we done here? Is this it? What do we still need to check? G of f of x. So that's what I want you all to try. Oh, y'all. Oh, sorry, it's my American accent coming out there. So, yeah. G of f of x. Okay. Give that one a try. So you go ahead, do it yourself. See if it ends up simplifying plain old x. It worked? Yeah. Okay. Good. So do we get just x then? Yeah. Looks like it, right? Okay. So in this case, the x in the g of x is replaced by 2x cubed minus 1. Okay. And then the minus 1 and the plus 1 cancel, and you get 2x cubed over 2. The 2's cancel. Cube root of x cubed is x. Okay. So, are they inverses of each other?
Yes.
Yes, right.
Can you cancel the cubes first, or do you have to cancel the two?
You could, let's see. I mean, you technically should cancel the 2's first, but if you do the cube root, it would be cube root of 2 over cube root of 2 times x, and then it would do the same thing. So, in that case, it's all right. Okay. In addition, we also need to remember how to find the inverse of our function. So find the inverse of, and we'll just do one of these. So we want to find the inverse of square root of 2x minus 3. Okay. If you remember hearing what Adric said earlier, what should we do first? Right, so instead of f of x, we could say now that's just the same thing as y. So we swap the x's and the y's. Right, and then we just basically solve for y. Solve for y. So square both sides.
Can we get out of here later now? Because we have like a shortened day. Can we get out of here late?
No, we get out earlier.
Oh, we do?
Same, yep,
Get out at 8:25. Flex was taken away though.
Right, so maybe other classes might, but we're before Flex affects the schedule anyway, so other classes might be a little bit later.
Yeah, third is like regular.
And then divide by 2, right. Y equals x squared plus 3 divided by 2. Don't forget you can break up the numerator over that denominator and make it just 1/2 x squared plus 3/2 if you like. Okay, just keep that in mind, right? We can break that up. Sometimes, it can be written, this way or that way, whichever way. And so then we can say, once we've done this, f inverse of x equals 1/2 x squared, oh, my 2's are teeny, there we go, plus 3/2. And that's the inverse of f of x. That is exactly something we're going to be doing here in a little bit. Okay? So, questions on any of that?
Do you always write on the back of the attendance sheet?
I like to reuse paper, recycle, looking out for the environment. I am an explorer. Want us to make sure those trees are around for later. We go exploring. All right. So, I've got a little exploration of your own to do. Okay. I didn't plan it this way. It just happened to work out. But of course, I don't believe in coincidences. So, what you're going to do, we're going to do a little investigation about the derivative of an inverse. Okay?
Are we getting a grade for this, can we?
Are we getting ready?
Yeah, can we?
What are you worried about, Mackenzie?
Nothing. I'm worried. I'm really worried.
Emma is really worried.
She needs some poison, I think.
No worries.
I'm worried. Doesn't matter what I do, I get.
Yeah, because
That's
I'll
the
tell you.
spirit. You've given up on it.
Y'all, I just gotta.
You gave up on it.
Right back where I started.
Good round up at
Yeah, we did get a grade.
Oh, that's awesome. Did we not get a grade for this?
Yeah, but we're gonna need out of here on March. There's a thing.
Well, the idea is whenever I put the answers up, you then correct it before you turn it in. That's the point. Well, then that's okay. Yes, you can absolutely do that. That's why I put it up. So you go back, you fix your mistakes.
Somehow it's still like.
But don't forget, right, that you're...
Oh my God.
you gotta fix the work. Okay, you might know that, but other people might just hear, I'll just change all my answers.
Can we get a grade for this?
And then, so...
I'm back at a 79.
Oh my God, you guys.
So, real quick here, I'm not gonna do the whole thing for you, but I just want to kind of review it a little bit before I cut you loose. Okay? So, number one, you're going to be graphing functions, both x squared, but only considering it for x greater than or equal to 0. Okay? I can show you how to graph only for x greater than or equal to 0. So let me show you that. So if you take your graphing calculators out, okay, we want to graph x squared. Who doesn't have a calculator? Ninja Cat forgot a calculator back at the dojo. Jill needs a cat. Oh, Jill, that's right.
What's the homework? Can we go back to...
Really crawl around with your calculator.
I want to get it.
I'm going to do some calculations about how much eucalyptus it ate today.
No, I like it. It's like crinkly and shit.
Okay.
Did you prep yourself?
What we always talk about. Koalas are in Australia. They eat eucalyptus. I don't know, it's a fact. It's like you guys saying, the cow ate a lot of grass today,
Koalas sleep an average of 18 to 19 hours a day. They're really cute. They're only a week.
That's right.
So,
So, anyway, real quick here. If you only want to graph x squared for x values greater than or equal to 0, here's how you do it. You take your graph there, your function, and you do divided by, okay, and then parentheses, and then you type x, and then we want to find that greater than or equal to symbol, and that is located in second math. Okay? Maths. It should be maths. They wrote it wrong on your calculator. And then we'll put it down here. There you go, number 4, right? Greater than or equal to 0. And then, right, at this point you can graph it, but of course we also want to graph the square root of x as well. So I'm going to put that in. Oh, and I hit
Where was it under math?
finances. Second math is in the test.
Oh.
Test.
Ooh.
Menu. And that's a weird window. Let me fix it.
Mr. Wood, I feel like you sat, like, last night, you played a recording of Australian people talking and just slept while they talked to you.
What? This is how I naturally talk.
Okay.
It's the American accent. I just listen to you all talk and I'm like, got it, nailed it.
Mr. Wood,
Yeah.
can you show me how to change the window?
Yes.
I'm really bad at it.
How to adjust it, you mean?
Yeah, like I can never.
Hey, why
So,
is it giving
well,
me an error?
the standard viewing window, if you just press zoom and then 6, gets you to the standard viewing window. Okay, so I'll help you in a little bit.
Yeah.
What-
Left your y equals like 1 more second.
is that all you need? Okay.
Y
Sorry?
equals for 1 more second.
Y equals.
Oh, oops.
So, this little technique is useful also for when you're graphing piecewise functions. You can actually do this for piecewise. The way this works, let me just kind of describe this here, okay? When you do this division symbol here, and you put this in your calculator like so, when your calculator is calculating the different values here, for x values greater than or equal to 0, it's going to return a 1. And so taking your function, dividing by 1, doesn't do anything to it, but it graphs it normally, right? If, though, you're going to be graphing for x values that are not greater than or equal to 0, this returns a 0. Okay, it's like a truth statement. If it's true, it returns a 1. If it's false, it returns a 0. So, for x values greater than or equal to 0, it's going to return a 1, but for all other x values, it's going to return a 0. Now, what happens when you take something and you divide it by 0? It's undefined. Your calculator won't graph it. So that's why it stops for any x values less than 0. Okay? So that's how that works. So that's how you can graph piecewise. All right, now, you might not believe me just looking at this here that those are inverses, right? They don't quite look like inverses, but the reason for that is because your calculator has a rectangular screen. And so you can actually fix it to make a square screen if you go to zoom and you go to zoom square. Number 5. And there it is. A little bit better.
Mine's automatically square.
Oh, well, that's good. Okay. So anyway, there are the graphs. More importantly, though, I want you to now go ahead and answer these questions. So first of all, I want you to verify those two functions are inverses. You should remember how to do that. We just showed it. Okay. Then I want you to write the ordered pair for f of x at x equals 3. So you need to come up with the ordered pair there, the x coordinate, y coordinate. You already have the x, find the y, right? Yep. And then determine the inverse point on g of x. Remember, if we had a point, and we wanted to find that inverse point, what should we do? Right, okay? And then number 4, using the feature on the calculator, I want you to find the slope. Okay, so I showed you guys how to find the derivative using your calculators, right? Yeah. Should have. Yeah?
I don't remember.
No? Okay. Second trace, you go down to dy dx. There it is, and you plug in whatever x value you want to find, where you want to find the derivative. Okay. You may need to turn off one of your functions. You may need to only do it one at a time. You might not be able to have them both graphed at the same time.
Use the up and down
To do it, or you can use up and down arrow. There we go.
Mine looks like I need to be able to save
Okay.
it now, and I can't.
And so then go ahead and do number 5 as well.
It makes your brain work or something.
So yeah, go ahead. Give these a shot. I'll come around and help as necessary. All right, so kind of leave that up there.
Help my graph look like yours does. The x squared is like an x squared. It's like a straight line.
Degree be in degree or radian?
Well, there's no need for degrees or radians, but every other day, radians, though, right? Radians.
Look at my x squared. Straight line.
Well, that's because you didn't put parentheses around your x greater than or equal to 0. So it's basically just taking your graph and taking the x squared and dividing by x, creating...
Yeah.
Does that fix it? Caitlin, let me know if it does.
Yes, it does.
So you want to find f prime of 3. So, second trace,
I like that.
go down to dy dx, number 6. Okay, now make sure you're on the right
And I.
curve. You're on the x squared curve. Is that yes? Okay.
There's a whole bunch of random people going. Like I was in Walmart yesterday and I saw her.
Same thing for the other one, make sure you're on the other
And then she's like,
function.
so you're my partner, and I was like, maybe. And she just screwed me.
Oh, the battery is right, okay. Let me see. Okay. Well, I don't think
Are you guys?
I've got one calculator right here. Yes, I would use to come up with the fraction that is equivalent to that decimal.
I'm on the phone for every time if we know the person.
So, for you? Trouble. Which I mean, like, from a mother's perspective, I understand. You know what I mean? Stupid.
I'm an explorer,
I can
lots of money,
understand from a mother's
find
perspective.
treasure all the time. What's
Guys,
that?
I eat lunch at 9:30.
You read that, didn't you?
Ew.
Right, which is different. For example, you have a decimal that's .666666666. We know that's 2/3. But if you just round it to .6, that's a completely different fraction.
What's homework?
You should, now, you can type it in your calculator, .666, .166666666. You just do it a bunch of times, hit Math and enter, run it to a fraction. Tricks the calculator. Bathroom?
Oh no, I was just
Oh.
holding this up.
Oh, it's gonna be coming my way. What's up, Steve? Yeah, looks good. Find the value of the derivative of an inverse. What's an inverse? G of x. They're inverse. Find the derivative of this at home.
If you get someone that's higher than
Other function. Everybody else for that. What's this question? Number 5, it's asking you to find the slopes for two different x values. Well, sorry.
No way.
It says in the directions what to do. Say what?
Okay, me.
Yep, just like that. Yep. You answer the questions that are being asked right there in the directions. Yes, you spotted me from far. Yes. A wild little midnight has appeared.
I hate that. That's weird.
Like here, right there, it says f inverse prime of x, which is equal really to g prime,
Yeah?
and then at 9 is when you
I did number 3.
So use your calculator. Well, so go and do it like you normally would. Not table. GYDX. Back to the graph. Second trace. It's alright, it's not a crocodile, I'll bite you. Hippo, they're dangerous. That's right. You think they're friendly now. Here's how you know. I'm going to move your arrow along there and keep up. My cursor is on x squared. So when I go to then your second trace down to dy dx, I'll be taking the derivative of
When are you giving
this
it back?
curve,
I just changed the number.
and I want to find the value at 3. So plug in 3, enter.
That was the one that German shot. German shot.
That's the value of the slope there. So then now, right, you got to use the arrows. So are those contacts uncomfortable? Do you normally wear contacts? Okay, so I feel like if I, because I normally wear contacts, I'd probably be, are they hard contacts, like do they, is it easy? They're soft, so they like bend and stuff? Okay.
I never texted me back in the morning. I wake up and I have a couple texts I never text me back.
Man, your eyeball. Kind of there, you didn't get rinse it off
Yeah,
very
me
well.
either. Yeah. Oh, I usually wake up at 7:10 and go to the shower. Yeah. And like yesterday, I woke up at 7:10. Did you see my hair wet when I came here? Oh, dude, I gotta go up to Anton today. I gotta find Anton. We gotta do our handshake. I'm so excited. He doesn't even know I know.
tricky calculation.
It's not
Oh, shit. 1.1 without the million sixes at the end. Boom, there it is. On 6.
Guys, how do you do number 3?
Oh, no.
Do number 4.
Can someone teach me how to do number 3?
Point of the slope.
You had to do
4.
Like at the peach.
So you just use your use the feature on your calculator to determine the slope at the ordered pairs found in the steps above. So it's the dydx command. That's all it is. You do for the first one.
happens when I do that command?
Well, I'd say you need to try it again because here's the thing, Mr. Widmeyer, I'm not going to be able to help you on the test, so you need to figure it out. Now, if you come up with an actual like what do I do next kind of question, I'll be able to help you, but I'm not going to
I
leave you
did
through the
that.
whole thing.
Now what? How do you determine the inverse point on G-back?
All right, Jill. Sorry. Question.
Do the
How do you
dydx
spell it?
Here.
Num.
Okay, you probably
What was that? Second?
of the
Oh, second?
Yeah.
You see, so you kind of use your arrow.
Second.
Ooh.
Second trace?
No.
Oh, you there you
Second
go.
mode,
Okay.
second.
When you do that, you see right now.
Second
you're calculating
moving graph.
the derivative.
Yeah, I got it. It's second trace.
Great question. You're going to use your down arrow.
Yeah.
Drop it down to the other side.
Now what?
Now we type in 9. That's
So bad at coding today.
which
I don't get it. Why not?
How do you do that?
Enter. Boom. See? Oh, that wasn't your question. Come on. Repeat these steps. Order pairs. So, what do you do? Write the order pair for f of x at x equals 1.5. So you 1.5 humble blocks. And then 2 humble blocks. Just come up with the pairs again, just like you did here. And then you do the same thing as you did here. We're going to find f prime of 1.5. And I want you to find f inverse prime of 1.5. Oh, not 1.5, sorry, I'm the other whiteboard. See what you did here, you used 3 and the 9.
So funny.
We had 10 minutes left.
Oh, is that right? Okay.
Yeah.
All right.
It's weird that this class is shortened so much.
Hey, you should not talk like this.
Oh, is that right? Why is that? They're mean.
It's really annoying
What are they-
your guys left it this way and then theirs is that way.
How are they mean?
Taylor Riggs is the meanest person you will ever meet.
They're so mean.
No, Mr. Wood. Mr. Wood, you don't understand. Taylor Riggs is the meanest person you will ever meet. No, she actually, okay, we're like best friends, but like, it's actually funny because everyone thinks she's this sweet, like innocent girl, but really it's like
She's not.
opposite. It's really funny.
I mean, I don't put it past anyone to do dumb stuff or to be jerks. It can happen to everybody. So,
No, she's actually nice.
yes.
How'd you get one?
She's just like a, she's actually just like a huge bitch. Like you wouldn't expect it.
I feel like she's
But I
like,
couldn't say what to say. Like she really,
I don't really know her.
like you know how like she's like quiet, like she doesn't talk to anyone?
Yeah.
Because she doesn't like anyone. She's like, I don't want to talk to people I don't like. So it's not like she actually goes up to people and say, I don't like you. She just
We're gonna-
doesn't
yeah,
talk to
we're
them,
gonna,
she doesn't like you.
Yeah.
Because
Not
there's
you, in general.
a little bit of a challenge, and I would like to get this done, so we're gonna kind of go over it here now. All right. I'm gonna like skip number 2 because hopefully everyone was able to verify that those two functions are inverses of one another.
Yeah.
Okay. So number 3 though, we do want to write the ordered pair for f of x at x equals 3. So what is the ordered pair there for f of x?
3, 9.
3, 9, okay? Which then makes the inverse point on G 9, 3. Right, so it's flipped around. Okay. Number 4,
Yeah, this is why I didn't ask.
alright, using the feature on the calculator to determine the slope at the ordered pairs found a step above. Wait a minute, that doesn't even make sense. I'll have to fix that grammar.
Use it too.
Some weird Australian grammar there. But basic, I don't have any calculators, that's what my problem is. Okay, so anyway, the idea is you're going to use...
Show it on mine.
Yeah,
I
okay.
heard second, I heard take second.
So, okay, I see. So again, we've got our graphs. We go to second trace, which takes us to the calculate menu. We want to go to dy dx. That's the value of the derivative, and we plug in the point. Okay, so dy dx. Now, the first thing we've got to make sure of is that our cursor is on the correct graph. Okay, so x squared is the graph we're on right now, which is what we want, because that is f. F is the x squared there. And to find f prime of 3, we're going to type in 3 and hit enter. And there it is. 6 is the value of the derivative, the slope. Okay, of our function. Now for the next one, we want to find the slope, m, of f inverse of x. Okay, it's really f inverse. I think it's a prime there. It looks like it is. So, which is the same thing, right, as g prime. G and f inverse, that's the same thing, right? We define g to be f inverse. So, anyway, g prime, so we now press second trace again, go down to number 6. But now if you look, our cursor is still on, we're still targeting that x squared, which we don't want. We want the other one. So how do we get down there? You press the down arrow, and it jumps down, snaps down to the square root of x. See? It's all along there now. I'm going to type in 9, and there it is. 0.166666666. Now, if you don't recall what that decimal is as a fraction, you can trick the calculator into doing it for you. Here's how. You type in your calculator, 0.1, and then a bunch of 6s. Doot, 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 doot. Math, enter, enter. And look at that, 1, 6. You should never, ever, ever, okay, round. We want to get precise values there.
When I do that, it just still gives me 0.1666.
You didn't type in enough 6s then.
You need at least 10 digits.
You got to like overflow the calculator with 6s, and then it'll just give up and say, "Fine, here's the fraction."
True.
And there it is. All right. So yeah. Anyway, next one. It says repeat the step above for the ordered pairs. A, f of 1.5, and B, f of 2. So our ordered pair there then would be what? 1.5, comma, did anyone figure out the matching y coordinate? 3? Thank you.
No.
It's not 3. Okay.
No, never mind.
Wait a minute. 1.5 squared, I'll just do it real quick. 2.25. Yeah, that's right. There we go. I should have known that.
And then I got 2 and 4.
Wasn't thinking right. 1.5, comma, 2.25. That's for this. Whoops, not this way. Sorry, this way is how it's divided. And then this one will be 2, so then 2 squared is 4, I don't know even why. My maths are off today. There we go. 2, 4. Okay? So we're going to do the same thing. We want to find f prime of x. So, dy dx. Let's see here. 1.5. There it is. 3. Okay, I'm going to go ahead and do the 2 as well because we're already on the same graph there. So I'll go for the bottom one. It's going to be a slope of 4. And then we want to do the f inverses, right? So that means derivative. And we want to snap a pointer down to the other curve. And I want to find it at, what, 2.25, which is 0.33333. But what is 0.3 repeated as a fraction? 1/3, very good. And then let's try the other one here. It's 4. And it's dy dx at 4. Oh, did I do that right? I was on the wrong curve. Whoops, sorry. Yeah, there we go. Okay, sorry. 4. Yeah, 0.25, which we all know is 1/4. Okay, so right. So if you see here, we evaluated the function, okay, the derivative of the function, okay, at 6, and then we evaluated at the inverse point the derivative of the inverse, and it was 1/6. Okay, here again, we evaluated the function's derivative, okay, at 1.5 to be 3, but then we evaluated the inverse, the derivative of the inverse at its inverse point, 1/3, and then 4 was the slope, and then 1/4. So what do we see here maybe is the relationship between these two things. Not inverses,
They're
reciprocals, right, okay, it's 1 over your slope, okay, and that's, okay, yes, the value of the inverse of the derivative,
How many work?
okay, is the reciprocal, okay, of the original derivative. Okay, the value of the inverse of a derivative, or I should say the derivative of an inverse, sorry, the value of the derivative of an inverse. And yes, it is a different thing to say the inverse of a derivative and the derivative of an inverse. They mean two different things. So, the value of the derivative of an inverse, okay, is the reciprocal of the original derivative. Alright? So, we're going to run out of time. If I continue on, we do have a little bit more to do, so we'll finish it up on Wednesday. Okay.
It's called Monday or Tuesday.
It's going to be a long weekend. You guys been working real hard, you know, so just go ahead and take 2 days off, Monday, Tuesday. It's fine.